Hello everyone. Our lesson today is lesson 5, which is the relation between the chords of a circle and its center. First, if we have a circle M like this, here we have circle M, okay, and we have chord AB, here A, B, and we have another chord CD. Okay, so we have here two chords AB and CD. We want to get the distance between AB and the center of the circle. Okay, the distance between the AB and the center of the circle must be perpendicular to the chord. So to get the distance between the center here and the chord AB must be perpendicular to AB. So here must have perpendicular to AB. Okay. And also to get the distance between the chord CD and the center M must be perpendicular to the chord. So here we have the perpendicular to CD. Let's take here X and here Y. So here MX is the distance between AB and CD is the distance, and MY the distance between CD and the center. Okay, again, to get the distance between AB and the center or CD and the center, the distance must be perpendicular to the chord. Okay, we have theorem 1 here. If chords of a circle are equal in length, then they are equidistant from the center. It means here, if we have in another figure, okay, if we have two chords like AB equals CD, then we get MX equals MY, and we said MX must be perpendicular to AB and MY must be perpendicular to CD. So first theorem, it's called if we have two chords are equal in length, then we have the equidistance from its center. And we said before, equidistance, distance, it means we have perpendicular, okay? And we have the converse of the theorem. Chords which are equidistant from the center are equal in length. So here the converse. If we have MX equals MY and also MX perpendicular to AB, MY perpendicular to CD, then we get the two chords are equal, which is AB equals CD. Okay, let's take some examples. Number 1. Here we have MX equals MY. Okay, here MX equals MY. Okay, AB 16 centimeter. Here AB is 16 centimeter. MX is 2K. Here 2K. CD is 5K plus 1. Here CD is 5K plus 1. Then complete without proof. Okay, we want to get the length of CD. Okay, here we have MX equals MY. Here the converse of the theorem. Okay, so MX equals MY and MX perpendicular to AB and MY perpendicular to CD. Then we get the two chords are equal. The two chords are AB equals CD. So we have here, since first we have MX equals MY and MX perpendicular to here AB and MY perpendicular to CD. So we get AB equals CD. Okay, here we know the length of AB, which is 16. So the length of CD also is 16 centimeter. Okay, number 2, we want to get the value of K. Okay, here we have CD is 5K plus 1. And we said in number 1, CD is 16 centimeter. So we have here 5K plus 1 equals 16. It's an equation. Move one in the other by -1. So 5K equals 16 minus 1. So we have here 5K equals 15. We want to get 1K, so divided by 5. So K equals 15 divided 5, which is 3. So the value of K equals 3. Let's take number 3. MX. Here we know MX is 2K. Here MX equals 2K. By substitution, K, we get the value of K, which is 3. So 2 times 3 equals 6. So MX equals 6 centimeter. The last one, MB. Here we have MB. So join M with B. We have here a triangle. We have here, we shaded the triangle here. The triangle MXB. We have the length of MX, which is, we get 6 centimeter. Okay? And we know XB. How? We said in lesson 1, we have MX is passing through the center of the circle, MX perpendicular to AB. So we found bisect. So MX bisect AB. It means XB equals XA. Again, we said we have 3 corollaries. As we said, passing through, bisect, and perpendicular. Here we have passing through, and we have perpendicular. So we get bisect. We have here perpendicular here. We have also passing through the center, so we get bisect. So MX bisect AB. It means XB equals XA. So 16 will divide it to 2. 16 divided 2 equals 8. So XB equals 8 and XA equals 8. Here we have right angled triangle MBX. We have the length of MX 6. The length of XB 8. So to get the length of MB by using Pythagoras theorem. Okay, so in the right angled triangle, MBX, we have here MX equals 6 centimeter and XB equals 16 divided 2 equals 8, as we said from the 3 corollaries. Okay, so by using Pythagoras theorem, MB equals square root 6 power 2 plus 8 power 2. Using your calculator, it will be 10 centimeter. So the length of MB equals 10 centimeter. Okay, let's take another example by proof. Number 2, here we have ME perpendicular to AC. Okay, here we have C and B. Okay, and F is the midpoint of AB. Measure of angle C is 65. And ME equals MF. Find measure of angle A. We want to get measure of angle A. Okay, as we said, every given, we get the result from every given in the example. First, we have here, F is the midpoint. Okay, and MF passing through the center. Midpoint, it means bisect. So bisect passing through the center. So the third one is perpendicular. Again, we have MF passing through the center and MF bisect from midpoint. Okay, so the third one is perpendicular. Okay, right. Here we have the proof. First, since F is the midpoint of AB, and also since MF passing through the center of the circle M. It means MF is perpendicular to AB. Okay, and let it number 1. Okay, here we have, it's a given, ME perpendicular to AC. So ME perpendicular to AC. Okay, and we have ME equals MF. Okay, so we have here ME equals MF, and ME perpendicular to AC, MF perpendicular to AB. Here the converse of the theorem. So the two chords are equal. The two chords here, AB equals AC. So we get here AB equals AC. AB and AC are two sides in the triangle. Then the triangle here is an isosceles triangle. So the triangle ABC is an isosceles triangle. It means the two base angles are equal. Here, two base angle, measure of angle C equals measure of angle B. So we have here measure of angle B equals measure of angle C, which is 65. Okay, we want to get measure of angle A. Okay, measure of angle A is the third angle. Any triangle, the sum of measures of the interior angles is 180. So measure of angle A is 180 minus 65 plus 65. So we have here, since the sum of measures of the interior angles of triangle ABC is 180. So measure of angle A equals 180 degree minus 65 plus 65, which is 50 degree. And this is the required. Okay, in this example, if we want to get measure of angle EMF here, as we said in the previous lesson, AEMF is a quadrilateral. We have measure of A50, measure here of E90, F here 90. So 360 minus 90 plus 90 plus 50, which is 130. Okay? Let's take another example, number 3. Here we have in the opposite figure, X and Y are two midpoints, okay, of AB and AC. Okay, AB and AC are two equal chords. Prove that XD equals EY. Okay, here, as we said before, every given in your example, we get the result from every given in the example. First, we have here X is a midpoint. Okay, here MX passing through the center. So we have here midpoint, it means bisect, passing through. So the third one is perpendicular. So MX perpendicular to AC. Similar in Y, Y midpoint, MY passing through the center. So MY perpendicular to AB. Okay, let's write here first, since X is the midpoint of AC, and also MX is passing through the center of the circle M. Midpoint يعني bisect, passing through, so we have perpendicular. So MX perpendicular to AC. Okay, similar in Y. Here we have, since Y is the midpoint of AB, and since MY is passing through the center M, so MY is also perpendicular to AB. Okay. Here we have MX perpendicular to AC, MY perpendicular to AB. Okay. And AB and AC are two chords are equal. So that the equidistance here are equal. So MX equals MY. Okay, here the theorem. So here since AB equals AC and MX perpendicular to AC, MY perpendicular to AB, then we get MX equals MY and let it number 1. Okay, here we have MX equals MY. Okay, what about MD and ME? Right, ME and MD are two radii. Line segment joins between the center of the circle and any point in the circle is called the radius. So MD and ME are equals. So here we get since ME equals MD, here write the reason, two radii and let it number 2. What about subtract 2 from 1? The result here will be XD equals EY, and this is the required. So by subtracting 1 from 2, we get the required, which is EY equals XD. Okay? Thank you.